Hello, my name's Kelley Dugan. I'm a third-year PhD student in mechanical engineering at the University of Michigan, where I'm part of the Daily Design and Engineering Education Research Group. I work with Dr. Erica Mozioski, Dr. Shanna Daly, and Dr. Lisa Latuka. And today I'll be talking about our research on a particular problem-solving approach used in engineering in my talk titled Improving Complex Problem-Solving Success by Helping Engineers See the Whole Problem. This engineering research is complemented by methods and prior research in education and cognitive science. So, how do you solve a problem? I was drawn to engineering because engineers are problem solvers. There's many different ways to approach problem solving, and the approach that you take depends on the type of problem that you're working on. We live in a world where the problems engineers are working on are increasingly complex. Complex meaning that they have many parts that are very interrelated or interconnected with each other. Let's look at an example, ending the COVID-19 pandemic. COVID-19 is caused by a virus. In order to end the pandemic, we need to be able to see if people have COVID, we need to be able to treat people who are sick with COVID, and we need to be able to prevent further spread of the virus. And what we do for these things is affected by what everyday people think. Some parts are affected by getting FDA approval and resource availability. And in turn, some of these things are affected by governmental policies and resources. And so we can see that this complexity comes from technical considerations, such as developing the process for making vaccines, and social and contextual considerations, such as what people think about COVID, and their access to personal protective equipment or their access to the vaccine. And this complexity can make it hard for engineers to see the whole picture. If you're only focusing on the vaccine and getting FDA approval, you might not adequately consider public opinion. At the same time, focusing on public opinion alone is not enough. And so our goal is to help engineers see this whole picture. Complex problems that require attention to technical, social, and contextual factors are not new. For at least the last 50 years, numerous researchers and journalists have documented ineffective solutions and even failures that resulted from relevant parts of the problem either being ignored or not getting enough attention. One example from the 1990s is a German car manufacturer started using biodegradable wiring insulation. Why did they make this material choice? Because Germany's Green Party had passed a law requiring a certain percentage of car parts to be biodegradable. So we see environmental and political factors showing up. And when these factors interacted with time, failure occurred. So over time, the insulation degraded as biodegradable materials are intended to, and they ended up with masses of short-circuited wires and cars that didn't work properly. So we can see that it's important for engineers to look broadly when thinking about what factors can impact a problem or solution and consider the relationship between those various factors. So given this history of complex problems that require attention to technical, social, and contextual factors, we know that there are some gaps in the skills engineers have been learning. We see one of these gaps as not enough engineers who have the skills to see the whole picture and use their understanding of the whole picture in their decision-making. And our team believes the first step in addressing this gap is understanding and characterizing the specific skills engineers need to develop. In this case, comprehensive systems thinking, which is where our research comes in. So comprehensive systems thinking is a holistic problem-solving approach. And what this means is that it requires the identification of a range of technical, social, and contextual factors, as well as the inclusion of these factors and relationships between these factors in decision-making. There are conversations in engineering that acknowledge that attention to some of these social and contextual aspects are important, but it's rarely been discussed alongside systems thinking or interconnected with technical problem solving. And so the work related to comprehensive systems thinking has many parts. One part of that work is understanding how to assess or know if engineers are using comprehensive systems thinking. And this is important because having an assessment helps teachers make learning activities, and what is assessed often shows what's important or valued in a field. Our team searched for research papers that presented ways of assessing engineer systems thinking. And these ways of checking what people did or thought about systems thinking did not necessarily take the comprehensive approach that our team is specifically interested in, but we've looked at what's already been done in assessments and combined it with research we've conducted on how engineers describe their real-world approaches to solving complex problems to help us decide what to do next. And what we found when we looked at existing assessments was that most of the assessments focused on measuring what people know or what they do, which isn't necessarily surprising. But what was surprising is that of these assessments that focused on measuring what people know or do, most of them did not give explicit attention to social and contextual factors. They were generally focused on technical factors. So only 16% of the assessments push beyond the consideration of technical factors to explicitly consider a breadth of social, economic, political, environmental, and other aspects of the problem. But we know that complex engineering problems are by definition existing in a larger context. And so this finding is particularly important because we view assessments that are focused on measuring what people do as necessary for supporting skill development. And so to support skill development, our research team is making a comprehensive systems thinking assessment that focuses on what engineers know and do. In other words, we're creating a way to check if engineers are considering the whole problem in their approach. And once we finish making the assessment, we plan to share it with engineering teachers across the country. And our immediate goal is to support teachers at the college level in developing engineering students' comprehensive systems thinking skills. And our ultimate goal is to have more engineers with the skills necessary to appropriately address complex problems in context. I'll end by noting that there are many different kinds of research that involve problem solving in engineering. Our work is specifically focused on addressing complex socio-technical problems, which we see as one of the biggest challenges for current and future engineers. If you're interested in learning more, please check out the links posted in the video notes. Thank you.